Hello and welcome everyone. So by now we have discussed the introduction of prestressed concrete, and today we will be discussing some of the basic terms that comes very often in the textbooks, classes or the discussions on prestressed concrete. So we will be discussing that in alphabetical manner, and you must be remembering in the definition of prestressed concrete we discussed that prestressed concrete is also a concrete just like RCC. But unlike RCC, in PSC, we introduce certain amount of internal stresses before the external load is exactly applied. And these internal stresses are introduced of suitable magnitude and distribution throughout the length of the member. So these internal stresses which are introduced in the PSC are meant to counteract the stresses resulting from the external loads to a desired degree, okay, and we introduce these internal stresses in PSC by two methods. One is the pre-tensioning, other is the post-tensioning. So both are pre-stressed concrete only. So let us take first of all the pre-tensioned post-tension, and then we will discuss the post-tension. So in pre-tensioned pre-stressed concrete, the first stage is to tensioning the steel, okay. So you are seeing here in this figure also below, in this arrangement of Hoyer's line, this is called Hoyer's line, and here we have installed all the tendons, steel tendons, and all these tendons are screwed here in this arrangement, and they are applied with certain initial pre-stress, okay, of magnitude pi, let us say. So when the steel or the tendons are tensioned or stretched, after that we pour concrete on them and allow the concrete to cure and harden in the second stage. So second stage is the hardening of concrete, okay. So concrete harden generally in 28 days, and after that we cut these wires in between these slabs. So each of these slabs will be called as pre-tensioned PSC slab, okay. Similarly, the another method of manufacturing PSC is post-tensioning PSC, and in this method first of all we do the laying of the reinforcement bars, because we have to do first of all what? Hardening of concrete. So in the first step, hardening of concrete is done. So concrete has to be hardened after we have laid down all the reinforcement bars. So at the zero stage we can say laying of bars and ducts, okay. So these reinforcement bars we are familiar, and you are also seeing reinforcement bars for the columns, base slab, okay. So along with these reinforcement bars we also provide here some ducts. You are seeing these blue lines, these are ducts, and ducts are also called as sheaths. Through these ducts we will pass through the tendons later on when the concrete is hardened. So after laying down of these bars and ducts, then we pour concrete on it and we allow it to harden completely. And when the concrete is hardened, and then through these duct spaces which you are seeing here, we pass through all these tendons, okay. You are seeing these tendons are passing through these ducts, okay. And then we apply jacks or anchorage devices at the end, and then we screw them. On screwing, the pre-tensioning of the tendon is done. And if we want bonding, so we grout the spaces beneath the ducts. So that depends whether we want bonded or non-bonded. Sometimes there is no need of bonding or grouting because there may be corrosion on the tendons, okay. So and the second stage is the tensioning of tendons. So this is just the reverse process of pre-tensioning. So this method is done generally on the site itself, okay, as you are seeing in the pictures also. So now let us discuss all the terms that comes very often in the discussions of pre-stressed concrete. So here we start with letter A, and first of all we are discussing anchorages devices. See, anchorages devices are mostly used in post tensioning, because post tensioning is done after the hardening of concrete, and through those ducts we pass the tendons and then we tighten or stretch the tendons with the help of these hardwares, anchorage devices. And these anchorage devices are used for transferring the post tensioning force from the tendon to the concrete in the anchorage zone. So when we have stretched the tendons, then these tendons will be stretched as long as we have installed the anchorage devices on the pre-stressed concrete, and these anchorage devices will compress the concrete in the compression zone or the anchorage zone. So the entire concrete in the anchorage zone will be pre-stressed. See, we do tensioning in tendons, okay, and tensioning in tendons leads to pre-stressing in concrete. Remember this golden line, okay, pre-stressing in concrete. So first of all we do tensioning in tendons and it leads to pre-stressing in concrete, okay. Next is the bonded member. So as we have discussed, if we want a bonded member means what? Tendon and concrete are bonded, okay, both are bonded. So this bonding is done with the help of grounding, are bonded here with the help of grouting. So a pre-stressed concrete in which tendons are bonded to the concrete either directly or through grouting. See, the tendons are bonded in case of pre-tensioning, because first of all we lay down the tendons and then we power the concrete. So naturally there will be a direct bond between the tendon and the concrete, but in case of post tensioning we have to do the bonding through grouting only, okay. So this grouting is injecting the concrete slurry into the ducts. And next is the bonded post tensioning. It's similar to the bonded members, and here the post tensioned construction in which the annular spaces inside the ducts or the spaces around the tendons are grouted after stressing is done, and thereby bonding the tendon to the concrete sections, okay. Then the next term is the cable. Now cable is a group of wires or bars or strands or rods. So cable is just like you have seen the electric wire cables, and it has different numbers of wires arranged in a fashion like this, okay. And here I have shown you 7 wires in one cable only, okay. And cable can be not just a group of wires or strands, it can also be group of bars or the rods, okay. So this cable can also be used in place of tendons, okay. Now the next term is characteristic load and characteristic strength. Both of these terms you must be familiar in the RCC course. Characteristic load means what? The load which has 95% probability that beyond this much load the probability is very less, okay. The load which has 95% probability of not being exceeded during the entire lifespan of a structure. That means structure की लाइफ स्पैन में कभी भी कैरेक्टरिस्टिक लोड से ज़्यादा लोड नहीं आने वाला है, इसकी 95% गारंटी है, ओके. Similarly, characteristic strength means the strength of material below which not more than 5% of the test results are going to fall. Means the strength, characteristic strength is that minimum strength of the test samples जिसके नीचे only 5% of the test results will be falling down. Okay, so these are the characteristic load and characteristic strength. They are represented on the mean normal distribution curve like this, and when we take 95% percentage, then it becomes the characteristic load. Okay, and when we take 5% probability, then it becomes characteristic strength. Of course, the y-axis has to be different in both the curves. In one case it will be load, and in another case it will be strength. Okay, so this is how we represent characteristic load and characteristic strength on normal distribution curve. Now the next term is transmission length. See, transmission length is very, very important because it is the distance required at the end of a pre-tensioning tendons. It is used in pre-tensioning, and the distance required at the end of a pre-tensioned tendon for developing the maximum tendon stress by bond. So certain transmission length is very, very important in it. Now the next is creep. Creep is the property of concrete. Okay, similarly we will come to a term relaxation, and relaxation is a property of steel, but both creep and relaxation have similar meaning. Creep is a strain due to constant load or the sustained load constant है, पर टाइम के साथ साथ फिर भी स्ट्रेन बढ़ता ही जा रहा है. So such a time dependent deformation due to sustained load in the concrete is said to be creep. Similarly, in relaxation, it is the time dependent deformation due to sustained load in the steel. Okay, both have similar meaning, but creep is the property of concrete and relaxation is the property of steel. Now for calculating creep, we have to know the creep coefficient, and it is represented somewhere as theta also, and theta, it is the creep coefficient is the ratio of basically creep strain to elastic strain. Okay, next term is the final pre-stress. So before understanding final pre-stress, let us understand first of all initial pre-stressing. Okay, so there are three stages in pre-stressing. One stage is the first stage is the initial stage. Okay, second stage is the transfer stage. All right, and the third stage is final stage. See, what are these three stages? At all these three stages, the amount of pre-stress will be different. Pi is something else, Pt is something else, and Pf will be something else, because there is always, certainly there will be some losses occurring in all these stages. So initial pre-stressing, first of all try to understand initial pre-stressing. It is the pre-stress in the concrete at transfer. Okay, so initially we apply some pre-stressing in the tendons by stretching them. So when the tendons are stretched, suppose if this is the tendon, okay, and this is stretched here with Pi. Okay, so tendons are tensioned here by some force Pi. So this is the initial stage, and then at transfer, what happens? Transfer means transfer of this tension from the steel bars, tension from this tendons to the concrete in the anchorage zone. अभी ट्रांसफर पे क्या होगा? स्टील बार में जो लग रही थी ना प्री स्ट्रेसिंग, अब वो ट्रांसफर हो जाएगी कंक्रीट में. तो अब जो कंक्रीट में जो प्री स्ट्रेस आएगा वो होगा इनिशियल प्री स्ट्रेस फॉर द कंक्रीट. So tendons are always tensioned and concrete is pre-stressed. So this is initial pre-stressing of concrete. Similarly, there will be final pre-stressing of concrete. अब initial pre-stressing of concrete तो समझ में आ गया, ये यहाँ पे होगा ट्रांसफर पे. पर final pre-stressing क्या होगी concrete की? Final pre-stress means it is that value of stress which exist after substantially all the losses have occurred. अभी मैं सारे के सारे टाइप्स ऑफ लॉसेस पे डिस्कस करूंगा एक अलग वीडियो में. देयर आर 5 काइंड्स ऑफ लॉसेस and they all come under 2 categories, short term losses and long term losses. So when all these losses have occurred, what happens? We can write a final pre-stress will be equal to pre-stress at transfer minus summation of all losses. Okay, so this is a simple formula of algebraic formula. Okay, and final tension you can easily calculate. Final tension is the tension in the pre-stressing tendon. अब मैं कई बार बता चुका हूं, टेंशन जब भी बोला जाए तो वो टेंशन होता है टेंडन में, और प्री स्ट्रेस जब बोला जाए तो प्री स्ट्रेस होता है कंक्रीट में. ओके, सो फाइनल टेंशन इज द टेंशन इन द प्री स्ट्रेसिंग टेंडन कॉरेस्पॉन्डिंग टू द स्टेज ऑफ फाइनल प्री स्ट्रेस. जब सब कुछ लॉस हो चुका है उस समय टेंडन में कितना टेंशन है, सो दैट विल बी समथिंग एल्स and it will not be equal to PI. Okay, final tension will not be equal to PI. PI हमने शुरू में इंट्रोड्यूस किया था टेंडन्स में. ठीक है, नेक्स्ट टर्म इज द इनिशियल टेंशन. इनिशियल टेंशन अभी अभी डिस्कस किया है PI. ठीक है, इनिशियल टेंशन इज द मैक्सिमम स्ट्रेस दैट वी हैव इंट्रोड्यूस्ड इन द प्री स्ट्रेसिंग टेंडन एट द टाइम ऑफ स्ट्रेसिंग ऑपरेशन. सबसे पहले हमने टेंडन में PI लगाया. ठीक है, और जब ट्रांसफर हुआ तो ट्रांसफर के समय अगर हम कहें PT इज द ट्रांसफर ऑफ प्री स्ट्रेस, PT इज जनरली इक्वल टू PI एंड PI इज द इनिशियल टेंशन इन द टेंडन एंड PT इज द इनिशियल प्री स्ट्रेस इन द कंक्रीट. तो मैं लिख दे रहा हूं, यह है कंक्रीट के लिए और PI है टेंडन के लिए. ठीक है, so initial tension is the maximum stress that we have induced in the pre-stressing tendon at the time of stressing operation. Now in this list of terminology we have again put here post-tensioning and pre-tensioning, and you must be well aware now what is post-tensioning. Post-tensioning means what? In which it's a method of pre-stressing concrete. दोनों देखिए, दोनों के दोनों pre-stress concrete ही हैं. ठीक है, but in post-tensioning it's a method of PSC in which pre-stressing of steel is done against the hardened concrete. Means first of all hardening of concrete is done and later on we do the pre-stressing of steels. Okay, but in pre-tensioning it's a reverse way in which the tendons are tensioned before concreting. तो definitions को याद करना necessary नहीं है, but if you are understanding these definitions it's okay. Okay, and next term is relaxation. Relaxation, when we have discussed the creep, we have also discussed it. Relaxation is the property of steel bars and it's a time dependent strain for the sustained loading in the steel. Okay, sheathing is another name, you can call it sometime as duct also, but sheathing is generally done in case of protecting the tendons. Okay, sheathing is generally used when we are referring to protection of tendons. Why we want to protect the tendons? Because tendons are of a steel, so steel gets corroded when it comes in contact with water. So sheathing is a material which encases a pre-stressing tendon जो कि स्टील बार से बनता है, to prevent bonding the tendon with the surrounding concrete. And another function of sheathing का ये भी है कि it prevent the bonding of the tendon with the surrounding concrete. If we want non-bonded type PSC, then sheathing is done. And during concrete placement to provide corrosion protection, because in non-bonded we want no corrosion to the tendons, because tendons are the one which are stretched and they are the only responsible for introducing pre-stress in the concrete. Okay, so हम टेंडन को किसी भी तरीके से रिस्क उठाने देना नहीं चाहते हैं. ठीक है, सो सीदिंग एक कवर है, एक इनकेसिंग है, वो लगाते हैं. इसके दो फंक्शन है, एक तो नॉन बॉन्डेड भी बनाता है, दूसरा है कोरोजन से भी बचाता है. subsequently. Next is the shrinkage loss. Just like there is creep strain, similarly there is another property of concrete is shrinkage loss. And shrinkage is the loss of stress. All of these terms will become clear also when we will discuss the loss. Okay, one of the loss is shrinkage loss, and this is the loss of stress in the pre-stressing steel resulting from the shrinkage of concrete. concrete shrink करता है और उसके कारण से जो टेंडन है उसके अंदर जो हमने टेंशनिंग किया है, प्री स्ट्रेसिंग किया है, वो धीरे धीरे वो स्ट्रेस लॉस होता जाएगा एंड आफ्टर दैट वी विल बी कैलकुलेटिंग फाइनल प्री स्ट्रेस. एंड नेक्स्ट इज द स्ट्रेस एट ट्रांसफर. जैसा कि हमने डिस्कस किया, जब हमने पीआई फोर्स लगाया इनिशियली टेंडन पे, तब जो स्ट्रेस ट्रांसफर हो जाएगी कंक्रीट पे वो होगी स्ट्रेस एट ट्रांसफर. ओके, सो इट्स द स्ट्रेस इन बोथ द प्री स्ट्रेसिंग टेंडन एंड द कंक्रीट. एंड आई हैव सेड ऑलरेडी दैट PI is equal to PT. Okay, PI is the initial tensioning of the tendon. PT is the pre-stress in the concrete at transfer. ठीक है, so it's the stress in both pre-stressing tendon PI and the concrete PT at the stage when the pre-stressing tendon is released फ्रॉम द प्री स्ट्रेसिंग मैकेनिज्म. कई लोग सोच रहे होंगे कि सर ये पीआई और पीटी को अलग क्यों रिप्रेजेंट किया. देखिए, कई बार केसेस में क्या होता है कि सबसे पहले हमने, ये हमारा बेडिंग है, ठीक है, इस बेडिंग पे हमने स्टील बार्स लगाया और इसे हमने स्ट्रेच कर दिया. ठीक है, स्ट्रेच कर दिया, अभी हमने कंक्रीट डाला नहीं है, तो अभी इस समय इस स्टील बार में कितना प्री स्ट्रेस है, इनिशियल पीआई है. ठीक है, अब हमने इस पे कंक्रीट डाला. ठीक है, और कंक्रीट अभी हार्डन होगा कुछ दिन में, और इस कंक्रीट के अंदर ये अब भी है ये बार. नाउ व्हाट वी विल डू, आफ्टर 28 days वी विल कट दिस बार्स फ्रॉम हियर. नाउ एट दिस स्टेज वी कैन से, जब तक हमने कट नहीं किया यहां से, तब तक कंक्रीट में कुछ भी, कंक्रीट में भी पीटी कितना है, 0 है. जैसे ही आपने आफ्टर कटिंग फ्रॉम द मैकेनिज्म, ये मैकेनिज्म है, ठीक है, एक मैकेनिज्म है जहां पे हम प्री स्ट्रेस कंक्रीट बनाते हैं. आफ्टर कटिंग द PSC फ्रॉम द मैकेनिज्म क्या हो जाएगा, इमीडिएटली अब जो होगा PI जो था टेंडन्स में, वो ट्रांसफर हो जाएगा अब कंक्रीट पे. समझ रहे हैं बात को? तो उस समय कंक्रीट में आएगी PT इमीडिएटली. ठीक है, next term is tendon, and I hope you know this. Tendon is a steel element. Tendon is made of steel and it can be wire, it can be cable, it can be bar, it can be rod, it can be strand, or it can be a bundle of even such elements. It can be a bundle of wires, bundle of cables, bundle of bars also, which are used to impart pre-stress to the concrete. When the elements, when the tendons are tensioned themselves. तो ये गोल्डन लाइन हमेशा याद रखिए, टेंडन को हम टेंशन करेंगे तो कंक्रीट अपने आप प्री स्ट्रेस हो जाएगी. ठीक है, नेक्स्ट इज द ट्रांसफर. ट्रांसफर में हमने कई बार डिस्कस कर लिया, बट ऑफ कोर्स रिपीटिशन इज डन हियर, बट यू विल अंडरस्टैंड इफ यू विल वॉच द वीडियो कंप्लीटली दैट ट्रांसफर इज द एक्ट ऑफ ट्रांसफरिंग द स्ट्रेस. किससे और किस में, from the pre-stressing tendon to the concrete member. Okay, by cutting it from the pre-tensioning bed or the jacks, okay, or the mechanism. ट्रांसफर से क्या होता है कि मतलब है कि अब हमारा टेंडन से ट्रांसफर हो रहा है प्री स्ट्रेस कंक्रीट में. बस ये है बेसिकली, यहां से ट्रांसफर हो रहा है स्ट्रेस. So the act of transferring the stress in pre-stressing tendons from the jacks or pre-tensioning bed to the concrete members. So all of these terms which we have discussed just now will become even more clear when we will discuss more on pre-stress concrete in the upcoming series of videos. And even if you have understood them partially, you will surely understand them completely when we will discuss the PSC in detail, because it was just a discussion of terminologies. Okay, and we will continue our discussion like this only. So stay tuned and stay safe. Thank you.